All right, this is part 2 of parent functions and transformations. We've made it up to example 4, and it says graphing and describing stretches and shrinks. All right, so graph each function and its parent function. You can see I've already graphed the parent function here just to save a little time because it does take a minute to play with those and get them in the right spot. So I went ahead and graphed the parent functions. So we're going to graph g of x and h of x, and then we're going to describe the transformation. All right, and here's another study tip to visualize a vertical stretch. Imagine pulling the point away from the x-axis, so away from the x-axis. All right, easiest way to graph is to just pick some points. So we're going to just pick a couple points here. So let's say for g of x, let's say we pick x, and we're going to solve for g of x. All right. And again, we're just going to pick a couple negatives. So we're going to get -1, 0, and 1. We could even pick -2 if we wanted. Let's do that just to get the points a little bit further away from the graph we already have there. So let's choose -2, 0, and 2. All right, so if we do that and we plug -2 into g of x, -2, the absolute value is 2. 2 times 2 is 4. We plug 0 in, we get 0. 0 times anything is 0. And we plug 2 in, the absolute value of 2 is 2. 2 times 2 is 4 again. All right, let's graph this one in red. All right. All right, so if we have -2, 4, all right, -2, 4, so I need a point here. I need a point at 0, 0, and I need a point at 2, 4. All right, and we can draw our new graph. Don't have a V shape, so I have to draw it using 2 lines. Okay, so you can see that is g of x equals 2 times the absolute value of x. So it is that V-shaped graph, but you can see how it is pulled away from the x-axis. All right, h of x is a quadratic, so the parent function is y equals x squared, or f of x equals x squared. All quadratic functions have a highest degree of 2. And this one says graph h of x 1/2 times x squared. So we're going to do something very similar. Let's see. We're going to say let x equal whatever we want it to be, and then solve for y, or h of x. All right, so we can, let's do negative. This is going to be multiplied by 1/2, so we should go ahead and do multiples of 2. So let's just do -4, 0, and 4. We could have done -2, but then it's going to be halved anyway, so it's going to be smaller. So again, you can choose any x's you want. X is your independent variable. So you get to pick x, plug it in, and solve for y. All right, so always do powers first. So -4 squared. A number squared is going to become positive when it's squared, so that's going to be 16. Half of 16 is 8. 0 times anything is 0. 4 squared is 16. Half of 16 is 8 again. All right, so that gives us some points to graph. So let's see, we got -2, 4. And this is a 10 by 10, so that should be 8. And I've got 0, 0, And I've got 4, 8. All right, so that gives me all points where my parabola needs to go. Except I only went over 3. Give me 1 second. Let me correct that. Thought something looked right. It wasn't symmetric. 1, 2, 3, 4. All right, let's try that again. All right, got a red one going on. So let's see here. All right, so now we have graphed both g of x and h of x. So now it says to describe the transformation. So if we want to describe the transformation, let's start with a, g of x. So g of x, we can say that there's a vertical stretch of 2 because of this 2 here. And looks like they have the same domain and range. And everything else is pretty much the same. So pretty much you have a vertical stretch of 2. So g of x is a vertical stretch of the graph of the parent function by a factor of 2. All right, B part, h of x equals 1/2 x squared. We can say that h of x is a vertical shrink of the graph of the parent function because of the 1/2. So it's a shrink, and it's a shrink by a factor of 1/2. Again, the domain and range would be the same, and it's the same shape as the parent function. It just has, it's just going to be a shrink, which means it's going to be a little bit, it looks a little bit wider here, but it pulls out towards the x-axis. This one, the number here, 2, is greater than 1. It goes in towards the y-axis, and that's how you can tell whether it's a stretch or a shrink. Example 5, describing combinations of transformations. So combination means it's going to have more than one thing happen at a time. You can see there's a negative here, there's a +5, and there's a -3. So this one says, use technology to graph g of x and its parent function, then describe the transformation. All right, so let me pull up the calculator. We're going to use the calculator. If you don't have a calculator, we use the TI-84 Plus. Mostly in this class, you can get the emulator here like I have on your computer, but to have a handheld one is best. This is what we use for state testing. It's also permitted for the ACT, so I suggest getting some kind of TI-84, TI-84 Plus, whatever you can afford. You may be able to find a used one somewhere as well. All right, so using technology, we've got y equals, let's graph negative. And then to find absolute value, you have to go to math and arrow over to number. That's ABS is absolute value. And then you graph x plus 5. And then I'm going to arrow outside the absolute value and do -3. All right, so that is g of x. That's going to be in blue. And I want to graph the parent function as well, which is just the absolute value. Let's go back to math, number, absolute value of x. So the absolute value of x, that's the most basic form of this function. That's considered the parent function. All right, so the parent function's in red this time, and g of x is in blue. All right, so you can see the two functions are graphed on the screen here. And you know that it's an absolute value function. And so you knew that the absolute value of x had to be the parent function, which in this case is in red. So what is the transformation? You can see that the graph of g of x is a reflection across the x-axis, followed by a translation of 5 units to the left. So this moves you 5 units to the left, and this moves you 3 units down. So the negative makes it reflect across the x-axis. It makes it upside down. And this moves it 5 units to the left, and this moves it 3 units down. You can see it's still the same shape. It's just in a new position. All right, example 6, modeling real life. The table shows the height y of a dirt bike x seconds after jumping off a ramp. What type of function can you use to model the data? Estimate the height after 1.75 seconds. All right, so we're given a table here. I can see that x is in seconds, and it goes from 0 to 2. So you can see on the x-axis, I just put small numbers here. And then the height in y goes up to 24. So I went by tens here. You can use a different scale if you want. But what I want you to do is just pause the video and then just graph these points so we can determine what type of function we're looking at. All right, if you graph the points, hopefully you can see this looks like a quadratic function. It's an upside down quadratic, so it will be negative, but it is a quadratic function. So let's take our calculator and ask it to write a function for us. All right, because we will need a model in order to answer this question. So if I go to Stat and I go to Edit, that lets me enter a table of values. So if I enter this table of values, you can see I've already entered it here. Enter your x's in L1 and your y's in L2. Then you can go back to Stat and hit Calculate. And you can ask it to write you a linear, quadratic, cubic, quartic, all different types of functions. So we determined that this is of quadratic shape. So we're going to click 5. And this is going to write a function for us. So y equals, a is negative 16, so it's going to be negative 16x squared. So y equals negative 16x squared plus 32x and then I think it was plus 8. C is 8. Yep. So plus 8. All right, now that we have that, it says to estimate the height. Okay, the height is your y value. Estimate the y value after 1.5 seconds. This is your x value. So they're giving you an x value to plug in. So I'm going to have y equals negative 16 times 1.75 squared plus 32x plus 8. And that x is also going to be 1.75. All right, so I am running low on time, so I want you to take your calculator, see if you can figure that out, and then we'll talk about the answer. All right, hopefully you took your calculator and you typed it in just like the equation we wrote, negative 16 times 1.75 squared plus 32 times 1.75 plus 8. Remember, it asks us to estimate the height after 1.75 seconds. All right, does 15 make sense? We can look down here. 1.75 would fall in between 1.5 and 2. So it would fall in between 1.5 and 2. Does it make sense that that's 15? And it does look like that would fall along that curve. So that does make sense. So that helps you see that that is a reasonable answer. So y equals 15, and it's in feet, 15 feet. All right, that's all for this lesson. If you have any questions, please let me know.